Welcome to question 6 of the 2019 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video, we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 6, we have Fred owns a company that produces thousands of pegs each day. He randomly selects 41 pegs that are produced on one day and finds 8 pegs are faulty. For part A, we're asked what is the proportion of faulty pegs in this particular sample. So to answer this question, we just take the 8 faulty pegs and divide it by the total number of pegs in the sample, which was 41, and that gives 8 divided by 41 as the answer to part A of this question. In the examiner's report, we can see that 94% of students got this correct and that the question was done well. For part B, we're told that pegs are packed each day in boxes. Each box has 12 pegs, and we let capital P hat be the random variable that represents the proportion of faulty pegs in a box. The actual proportion of faulty pegs produced by the company each day is known to be 1/6. Our question is to find the probability that P hat is less than 1/6, and we want to express our answer in the form a b to the power of n, where a and b are positive rational numbers and n is a positive integer. So for this question, the first thing I'm going to do is let capital X be the number of faulty pegs. So therefore we know X is distributed binomially with n is 12 because that's how many pegs are in each box, and a probability of them being faulty is 1/6 because we're told that's the overall proportion of faulty pegs produced by this company. So therefore, the probability that we're asked to find, which is capital P hat being less than 1/6, is equal to the probability of capital P hat being less than 2/12, just so we can see the number out of the total of 12 rather than just the simplified proportion of 1/6. And being less than 2/12 is the same as having 0 or 1 faulty pegs in the box. So that's going to equal the probability that X, which is the binomial distribution we just identified above, being equal to 0 plus the probability that X is equal to 1. So if we find those two things and add them together, that will be equivalent to the probability that the proportion is less than 1/6. So therefore, the probability that capital P hat is less than 1/6 is equal to, and now we use our knowledge of the binomial distribution. So the probability that X equals 0 is 12 choose 0 times 1/6 to the power of 0 times 5/6, which is the probability of failure, to the power of 12. Then we add on that the probability that X equals 1. So that's going to be 12 choose 1 times 1/6 to the power of 1 times 5/6, and that power will be 12 minus 1 is 11. So that represents 1 faulty peg and therefore 12 non-faulty pegs. Now to get this question in the required format, we'll need to simplify this down, but we'll need to be a little bit clever about how we do it. So the first thing I'm going to identify is 12 choose 0. There's one way of doing that. And 1 divided by 6 to the power of 0, well, anything to the power of 0 is simply 1. So for that first term, we're just left with 5/6 to the power of 12. For the second one, 12 choose 1, we know that there's 12 ways that that can happen, and 1/6 to the power of 1 is just 1/6, and then we still have multiplied by 5/6 to the power of 11. So let me write out this second fraction first. So this will give 12 times 1/6 is 12/6, and I'm not actually going to simplify that because that will help to get it in the required format, which is probably one of the trickier things about this question. So we're going to have 12/6 times 5/6 to the power of 11. And then for our first term, we just have 5/6 to the power of 12. But we want the powers to match between that term and the second term that I've already got written here. So I want a 5/6 to the power of 11 on this side. So let me just write that out. 5/6 to the power of 11. And to get that there, I just need to multiply that again by 5/6 out the front. So that is what our line is now equal to. And what we can do is we can factor out that 5/6 to the power of 11, and that will leave behind 5/6 plus 12/6 gives 17/6 times 5/6 to the power of 11. So that is now in the correct form because it's now in the form a times b to the power of n. And that's because we can identify that a, which is a rational number, is 17 on 6. B, the base, is a rational number of 5 on 6. And n, the power in this case, is 11. So that's the answer we were looking for part B. From the examiner's report, we can see that very few students actually made it to the end of that question and got 2 marks. So almost 60% of students got 0 marks for that question. Almost 30% of students got 1 mark. So at least they gave it a go and got some reward for their working. So the method that they used is similar to the one that was shown on the previous slide. And the examiner goes on to say that most students recognize this as a binomial distribution. However, few managed to correctly find the 2 component expressions that were required. So that was the probability that x equals 0 plus the probability that x equals 1, where x was a binomial distribution. Even fewer successfully managed to manipulate these expressions into the format specified by the question. So it's really important in exams that you know how to manipulate your expressions to get them into a required format, which is a popular thing for VCAA to ask students to do in these kinds of exams. Another common error that was seen was to apply the standard deviation formula in this question, even though it didn't require it.